my dear friends, beloved students. Welcome back to C-Level Physics YouTube channel. My name is Srinivas. Already we are discussing oblique projectile. So in that we discussed time of flight, maximum height, horizontal range, etc. So in addition to those points, today we are going to discuss one crucial point. What is that? The complementary angles of projection. Right? What is meant by complementary angles? If sum of two angles becomes equal to 90 degrees, then those two angles are said to be complementary angles. See, theta 1 plus theta is 90 implies theta 1 and theta 2 are complementary angles. Okay. Similarly, if theta 1 is replaced by theta and theta 2 is replaced by 90 minus theta, then theta minus theta cancel, we left with 90. So, according to this statement here, theta plus 90 minus theta equal 90. Therefore, theta and 90 minus theta are said to be complementary angles. Okay. Here, I got an idea. For example, if one body is projected with some initial velocity twice, first at an angle theta, next at an angle 90 minus theta, right? With respect to horizontal, then how it affects range, maximum height and time of flight. So interesting, no? So let's move on to discuss. Okay. First of all, I want to examine the effect on range. Okay. What is the expression for range here? Range means R equal to U square sine 2 theta by G. Am I right? Range equal U square sine 2 theta by G. Right? Here range means R at theta. Yes, this is the expression for range when that body is projected at an angle theta with horizontal. Okay. Okay. This is what R at theta. Say that is R1. R at theta that is equal to R1. Say R1. Right? Right. One more time, the same body is projected with the same speed at the same place, but at an angle 90 minus theta with horizontal. So R at 90 minus theta. Say that is R2. So R at 90 minus theta, that is R2, equal to, as per definition or mathematical expression, U square sine 2 theta. Sine 2 into theta means what? 90 minus theta here, this time. It is theta, therefore sine 2 theta by G. Here it is 90 minus theta. So replace theta by writing 90 minus theta. So sine 2 into, it's not theta, this time that is 90 minus theta by G. Right? That is equal to U square sine of 2 into 90 minus theta. 2 into 90 minus theta, that is 2 into 90, 180 minus 2 theta by G. 180 minus 2 theta by G. That is equal to U square sine 180 minus 2 theta. Again sine 2 theta. Okay. So U square sine 2 theta by G. See here, U square by G. Sine of 180 minus 2 theta means again sine 2 theta. Okay. So what is this U square sine 2 theta by G? Nothing but R at theta. Right? That is R at theta. So therefore, see here LHS R at 90 minus theta becomes equal to R at theta. So what is the difference here? R at 90 minus theta equal to R at theta. Right? That also equal to R1 equal to R. Ranges are same. So at a given place, if one body is projected twice with the same speed, once at an angle theta, one more time at an angle 90 minus theta at the same place, then we have same range in both situations. That is R at 90 minus theta becomes equal to R at theta, otherwise R1 equal to R. Okay. So that's what the great result in case of range, in case of oblique projectile for complementary angles of projection. Same only I am representing somewhere here. See, suppose here body is projected like that, right? the body is projected with velocity u such that making an angle theta with horizontal, right? Okay, see, this is what parabolic path for one oblique projectile. Here body is projected at an angle theta with horizontal such that initial velocity projection is 2, right? So this is what parabolic path. Now here at the same place, now body is again projected with the same speed but at an angle 90 minus theta with the horizontal, like that. See, at an angle 90 minus theta but with same speed, like that. See, this is what velocity projection, right? But what is the angle made by initial velocity with horizontal means 90 minus theta. This is what 90 minus theta. 90 minus theta. Now what is the path of this projectile now? This is the path of projectile. This is the path of projectile. See, this is the path of projectile. Right? So this is the path for the same body next time, right? So here it is theta, here it is theta, it is 90 minus theta. So here this is what parabolic path for first time, this is what parabolic path for second time. See, in both situations body land at same place such that we have same range. So here r at theta becomes equal to r at 90 minus theta. R at theta becomes equal to r at 90 minus theta. Am I right? But the different maximum height. See, this is what maximum height for second projection. This is what maximum height for first projection. Okay. So this is what height at maximum height at 90 minus theta, for example. Now this is what maximum height at first time, that is h at theta. So here clearly they differ in gaining maximum height in both situations when body is projected at theta and 90 minus theta twice. Am I right? So h at theta not equal to h at 90 minus theta. Okay. H at theta is not equal to h at 90 minus theta. Of course, time of flight also may be different. So they differ in time of flight also. Am I right? So same can be viewed somewhere here, right? Somewhere here. Suppose coming to maximum height. Coming to maximum height. What is the expression for maximum height? H equal to u square. H is nothing but h equal to u square sin square theta by 2g. Am I right? So h means what? When it is projected at an angle theta with horizontal. H at theta. Say it is h1. Otherwise, say h theta that equal h1 equal to u square sin square theta by 2g. Right? Now see here h at theta. Otherwise h equal to u square sin square theta by 2g. At a given place g is constant. For a given speed of projection u also constant. Therefore h is proportional to sin square theta. H is proportional to sin square theta. H is proportional to sin square theta. Here as theta increases, sin square theta increases, implies h also increases. Right? So if theta increases, implies h increases. H increases. So between theta and 90 minus theta, if theta is greater than 90 minus theta, then h at theta is greater than h at 90 minus theta. If theta is greater than 90 minus theta, implies h at theta greater than h at 90 minus theta. Right? If 90 minus theta is greater than theta, implies h at 90 minus theta greater than h at theta. Correct? So between theta and 90 minus theta, right? If theta is greater than 90 minus theta, then height at theta is greater than height at 90 minus theta. Similarly, if 90 minus theta is greater than theta, then h at 90 minus theta is greater than h at theta. Right? Okay. Now coming to time of flights. Next point, time of flights. What is the expression for time of flight? T equal to 2u sin theta by g. 2u sin theta by g. Am I right? Time of flight equal to u sin theta by g. Here also at given place g constant. For a given speed of projection u constant. 2 already constant. So 2u by g constant implies t is proportional to sin theta. Again t is proportional to sin theta. Here also if theta increases, sin theta increases, implies to say that t also increases. So that is, if theta increases, implies time period also increases. Means time period in the sense time of flight increases. Am I right? Now between theta and 90 minus theta, if theta is greater than 90 minus theta, then t at theta is greater than t at 90 minus theta. Right? Okay. If theta is greater than 90 minus theta, t at theta is greater than t at 90 minus theta. Similarly, if 90 minus theta is greater than theta, now t at 90 minus theta is greater than t at theta. Right? So that's how one can estimate. Okay, here what is the reference? When a body is at a given place, when a body is projected with the same speed twice, once at an angle theta with the horizontal, one more time at an angle 90 minus theta with the same horizontal, then in both cases body will land at the same place such that we have same horizontal bend. That is, r at theta becomes equal to r at 90 minus theta. That is r1 equal to r. But body may differ both in maximum height as well as time of flight. Right? So between theta and 90 minus theta, whatever the angle is more, right? So whether it is maximum height or time of flight is more for that angular projection. Between those two angles, theta and 90 minus theta. Right? Okay. Of course, here we can write h1 by h2 equal to sin square theta 1 by sin square theta 2. Right? See here. Suppose here what is the expression? H is proportional to sin square theta, implies h1 by h2 comparison. That is h1 by h2 equal to sin square theta 1 by sin square theta 2. If you want to compare maximum height versus angular projection at a given place for a given speed of projection, then h1 by h2 becomes equal to sin square theta 1 by sin square theta 2. Right? Similarly here, see, t is proportional to sin theta. Here also you can compare like that. How can you compare here? See, t1 by t2 equal to t1 by t2 equal to sin theta 1 by sin theta 2. Suppose at a given place, two bodies are projected. At a given place, two bodies are projected with the same speed of projection, but making angles theta 1 and theta 2 respectively with the horizontal. Now, if you want to find the ratio of times of flight in both for both bodies, then t1 by t2 equal to sin theta 1 by sin theta 2. So you can estimate like that. So here it is h1 by h2 sin square theta 1 by sin square theta 2. Here t1 by t2, that is sin theta 1 by sin theta 2. Right? Okay, now among all possible angles, right, from 0 to 90, in a plane, what is the range of, suppose this is what on plane x, y plane. Now, what is the range of angular projection here in this plane? Means from between 0 and 90. See, this is the range of angular projection. Right? Now, here theta lies between 0 and 90. 0 less than, theta less than 90. Here theta not equal to 0, theta not equal to 90. So, this is what range of angular projection in a plane. Right? So, among all possible directions, for what angular projection range becomes maximum for a given speed of projection at a given place. That's what I want to know here. Among all possible directions at a given place for a given speed of projection, for what angle range becomes maximum, right? Okay. Now what is the expression for range? That is r equal to u square sine 2 theta by g, right? Maximum range. Maximum range. What is the maximum range? See here, I am writing somewhere here maximum range. Maximum range. R max. R max. When do we have maximum range? For a given speed of projection at a given place, right? When do we have maximum range? For what angle range becomes maximum at a given place for a given speed of projection? So if you want to know that point, take expression right now, that is r equal to u square sine 2 theta by g. Am I right? Range becomes equal to u square sine 2 theta by g. So at a given place g constant. For a given speed of projection, u constant, right? But what is variable here? Theta is variable, right? Theta is variable. So when r becomes maximum, when sine 2 theta becomes maximum. What is the maximum value for sine 2 theta? For sine function, maximum value is 1. So if sine 2 theta equal 1, that is maximum. For sine function, 1 only maximum. So therefore sin 2 theta becomes 1 maximum value. Then r becomes implies r becomes r max. R becomes r max. Now substitute here. Now r becomes r maximum. Okay. Now sin 2 theta 1 means whatever 2 theta here, sin 2 theta is 1 means 2 theta must be 90 degrees. Why? Because sin 90 equal 1. Sin 90 equal 1. So 2 theta becomes equal 90. What about theta here? Theta must be equal to 45. That is theta is 45. Theta 5. So among all possible directions for a given speed of projection at a given place, for all possible directions, projectile possesses maximum range when it is projected at an angle 45 with the horizontal, right? With the horizontal in a plane. So what about r maximum here? Theta. So we came to know that theta must be 45 to have maximum range for a given speed. So replace here, r becomes r maximum. That is r becomes r max, right? That is r becomes r max equal to u square sin 2 theta. What is theta here? 45. 2 theta means 90 degrees. 90 by g. So that is sin 90 means 1. Sin 91. So what about r max? That is u square by g. U square by g. So this is what maximum range, right? Maximum range means, suppose I am trying to project to an object at a given place with the same speed but in different directions. Okay. So let me examine for what angle of projection range becomes maximum. See. This is what xy plane, x, it is y. I am projecting like that. See, if theta 1, it is theta 2, it is theta 2, it is theta 3, like that, right? So here body taking parabolic paths individually like that. See, now this what for this projection, what is the angle of projection here? Theta 45 degrees. So especially for this angle of projection, body lands far away from the point of projection. See, far away from the point of projection. This is what origin. So here range becomes maximum, R becomes R maximum. Of course, if theta exceeds that 45 degrees, then you can have somewhat less range than this one. Suppose here this one body is projected with more than that 45 degrees, the theta is less than 45. This time again body possesses some smaller range like that. See, so among all possible directions here range is maximum, that is expressed in red like that. See, this one range becomes maximum. So what is the reference? At a given place for a given speed of projection among all possible directions, if body is projected at an angle 45 with the level ground, then body possesses maximum range. That means to say that it will land it far away from the point of projection, right? So that's what an important application. Okay. Now let us see, for complementary angles of projection, let us see what about maximum height, right? Suppose here one body is projected twice at a given place with a given speed of projection, once at theta, one more time at 90 minus theta with horizontal. In both cases, body get through some elevations. First at h1 or h at theta, next at h2, that is h at 90 minus theta. Now, what are the relations between h1 and h2? Let us examine. Right? Let us examine. Okay. Say, take a look here. First point, h at theta. Say this is what h1, that is usual form. When it is projected at an angle theta with horizontal, what is the expression? U square sin square theta by 2g. Right? Now h at 90 minus theta, for example, say this is what h2, that is equal to u square, see, u square sin square, instead of theta you can write 90 minus theta here, that is sin square 90 minus theta divided by 2g. See here g remains same. Why? Because we are doing experiment at the same place. U also same, means the speed of projection also same. Now sin square 90 minus theta means cos square theta. Obviously, that is same can be written as u square sin square 90 minus theta means cos square theta by 2g. Right? So here we have h1 and h2. Right? Body raises through h1 and h2 for complementary angles of projections theta and 90 minus theta at a given place for given speed of projection. Now, how h1 and h2 are related? First point, number one, sum of these two heights, h1 plus h2, that is h at theta plus h at 90 minus theta. See here u square h1 means u square sin square theta by 2g plus h2, otherwise h at 90 minus theta means u square cos square theta by 2g, u square cos square theta by 2g. That is u square by 2g is constant. See, kept comma, that is u square by 2g of sin square theta plus cos square theta. U square by 2g of sin square theta plus cos square theta, which is equal to 1. Why? Because sin square theta plus cos square theta means 1. So you left with u square by 2g. U square by 2g. Now here u square by g means what? R max. U square by g means R max. Am I right? U square by g means R max. That is R max by 2. R max by 2. Right? U square by 2g, that is U square by g means R max by 2. So what are the sum of maximum heights for complementary angles of projection? R max by 2, otherwise U square by 2g, where U means velocity of projection, otherwise speed of projection. Next one, number 2, result number 2. This time, what about product of magnitudes in case of complementary angles of projection? It is H1 H2 question mark. How to find? Here H1 means what? H1 means u square sin square theta by 2g. Now same can be written as u sin theta whole square by 2g. Can I write? Yes. H1 means u square sin square theta by 2g. U square sin square theta means u sin theta whole square by 2g. Implies u sin theta can be written as root over 2g h1. Root over 2g h1. Similarly, see, make it subject u sin theta whole square, that is 2g h1. That is u sin theta equal root over 2g h1. Similarly, h2. What about h2? Otherwise h at 90 minus theta. Otherwise h2. That is u square cos square theta by 2g. Means u square cos square theta means u cos theta whole square by 2g. Alright? U cos theta whole square by 2g. Now make it subject u cos theta whole square, that is 2g h2. If you write u cos theta implies u cos theta can be written as root over 2g h2. Root over 2g h2. So we have components of velocity projection. One is along horizontal, one more is along vertical. Now take expression for range. Range means what? R equal, now range equal to one of the expressions for range. Of course, range means u square sin 2 theta by g, otherwise 2 into u cos theta into u sin theta by g also. 2 into u cos theta into u sin theta by g also. Right? This is also expression for range. See, 2 ux uy by g. What is ux? Ux means this one, that is u cos theta. U sin theta means this one, that is 2 by g. See here, 2 by g into u cos theta means u cos theta root 2g h2. U sin theta means root 2g h1. Root 2g h1. Alright? So 2 by g into root 2g h2 into root 2g h1. Right? That is r equal to 2 by g into root 2 means 2. Right? Into root g means g into root h1 h2. Root h1 h2. Now g cancel. We left with r equal to 2 to the 4 root h1 h2. This is one most important relation. Range in case of complementary angles of projection. What is the relation between range and respect to max heights in both cases? That is r equal to 4 times root over h1 h2. Now on squaring both sides, r square equal to 16 h1 h2 implies. Now what about the product h1 h2 equal to r square by 16? R square by 16. So this is what product of maximum heights in case of complementary angles of projection. See, sum means this is what sum. h1 plus h2 equal to r max by 2, otherwise u square by 2h. h1 into h2 means r square by 16. Now one more relation is there, that is division. Number 3, division. That is, what is h1 by h2? What is h1 by h2? See here, h1 means this one, h2 means that one. Take the ratio h1 by h2. h1 u square sin square theta by 2g all divided by h2 means u square cos square theta by 2g. U square cos square theta by 2g. Am I right? So u square by 2g, u square by 2g cancel. We left with the sin square theta by cos square theta. That is a tan square theta. h1 by h2 equal to tan square. So this is what relation. h1 by h2 equal to tan square theta. So here, in case of complementary angles of projection, now here we have three relations in respect of maximum heights. First one, sum of the maximum heights, that is u square by 2 otherwise r max by 2. In the second case, product of maximum heights, that is r square by 16, which implies that range equal 4 root h1 h2. In third case, ratio of maximum heights, that is h1 by h2 equal tan square theta. Right? Now based on these relations, let us examine one numerical. Okay, based on sum and product in case of complementary angles. So before that I am writing relevant formulas here. Relevant formulas. What is the first one? Number 1, h1 plus h2. h1 plus h2 equal to h1 plus h2 equal to u square by 2g. Otherwise r max by 2. Number 2, h1 h2 equal to r square by 16. h1 into h2, that is r square by 16. Right? Number 3, division h1 by h2, that is equal to tan square theta. Tan square theta. Now I am going to rubbing up all this. Okay. Numerical. On numerical, in case of complementary angles of projection, in case of complementary angles of projection, sum of the heights h1 plus h2 equal to 50 meter for example, and product of maximum heights, that is h1 into h2 equal to 400 meter and meter, that is meter square. Right? Now find number 1. Find number 1, velocity of projection. Velocity of projection. And number 2, respective heights h1 and h2. Right? See, one body is projected at complementary angles of projection in a plane such that sum of their maximum heights raised 50 meter and product of maximum heights 400 meter square. So in that situation, find the velocity of projection as well as individual heights through which body radius. Right? Okay. Now, what is the solution? We have already relations between h1 and h2 in case of complementary angles of projection. Now, what is the sum of maximum heights h1 plus h2 equal to u square by t? Number 1, h1 plus h2 equal to, we know that u square by 2g, otherwise r max by 2. U square by g means r max. Right? Now here say g equal to 10 meter per second square. For example, g value 10 meter per second square. Right? If it is 9.8, you can take 9.8 meter per second square also. Now sum of the maximum heights, that is 50 equal to u square unknown by 2 into g means 10. Right? That is u square equal to 2 into 50, 100 into 10, 1000. Implies u means 10 root 10 meter per second. Right? U means root 1000, that is 10 root 10. Now coming to next point, how to find h1 h2? Already we have h1 plus h2 value. Right? h1 plus h2 equals so and so. If we are having h1 minus h2 also, then we can solve both expressions to find h1 and h2. Right? Now how to get h1 minus h2? Means take that relation a plus b whole square minus a minus b whole square equal 4ab. Right? From that formula, a minus b whole square equal to a plus b whole square minus 4ab also. Why? Because here we have product. So a minus b whole square We know that a minus b whole square equal to a plus b whole square, a plus b whole square minus 4ab, right? So a minus b whole square equal to a plus b whole square minus 4ab. Here we have h1 plus h2 value, also h1 into h2 values. So from which we can find h1 minus h2. So afterwards we can solve h1 minus h2 and h1 plus h2 to get h1 h2 values, right? That is h1 plus h2 whole square, that is 50 square minus 4 into h1 h2 product means 400, that is 400, right? 400, that is 2500 minus 1600, that is what? 2500 minus 1600, that is 4 plus 5, 900. So what is this value? In fact, h1 minus h2 whole square, that is h1 minus h2 equal to root over 900, that is 30 meters. Why? Because h1 minus height minus height will get again height, that is in meters. So we have h1 plus h2, that is 50 meters. See here, h1 plus h2 equal to 50 meter, h1 minus h2 equal to 30 meter, h1 minus h2 equal to 30 meter. So on adding plus h2 minus h2 cancels. So on adding h1 plus h1, 2h1 equal to 50 plus 30, that is 80. Now h1 equal to 80 by 2, 40 meter. See, this one number 1 implies we have h1 value 40, so 40 plus h2, 1 implies 40 plus h2 equal to 50, that is h2 equal to 10 meters. Okay, so h1 equal to 40 meter, h2 equal to 10 meters. So that's how we can find values of respective heights and velocity projection in case of complementary angles of projection, right? Now let us see relation between times of flight also. You can see relations between times of flight in the same case of complementary angles of projection. Now see, in case of complementary angles of projection, for example, the first time when it is projected at an angle theta, let the time of flight at theta, say it is t1, that is equal to, what is the expression, general expression, 2u sin theta by 2u sin theta by g, right? Now t at 90 minus theta, when the same body is projected at some other angle 90 minus theta with horizontal. Now what is the time of flight? Means the time on which body remains in air, that is equal to, say let me t2, which is equal to, replace theta by writing 90 minus theta. So 2u sin, it's not theta but 90 minus theta by g, which is equal to say t at 90 minus theta, that equal to t2 equal to 2u by g into sin 90 minus theta means again cos theta, that is 2u cos theta by g, right? Now let us see number 1, first relation, t1 by t2. See, t1 means t at theta, t2 means t at 90 minus theta. Say t1 by t2 equal to, t1 means 2u sin theta by g whole divided by t2 means 2u cos theta by g, 2u cos theta by g. So 2u by g cancel, we left with sin theta by cos, that is t1 by t2 equal to tan theta, right? Now coming to next relation, that is product. What will you get on taking product of t1 and t2 in case of complementary angles of projection? Now number 2, product t1 multiplied by t2. Okay. Now T1, T2. T1 means what? 2u sin theta by g. 2u sin theta by g into T2. What is T2? T2 means T at 90 minus theta. That is 2u cos theta by g. 2u cos theta by g. 2u cos theta by g. Right? Okay. Here we have 2 sin theta cos theta means sin 2 theta. Right? See here. U into u square. U square, right? U into u square, 2 sin theta cos theta, 2u square by g, 2u into u square by g. We left with sin theta, 2 sin theta cos theta, 2 sin theta cos theta by g also. One more, g into g is 2 sin theta cos theta means sin 2 theta. That is 2 into u square by g into 2 sin theta cos theta sin 2 theta by g. Okay, that is u square sin 2 theta by g means what? See, T1, T2 can be written as u square sin 2 theta by g means range. That is 2 by g into u square sin 2 theta by g. See this one. That is u square sin 2 theta by g means range. That is 2 by g into r. That is 2r by g. T1, T2. 2r by g implies from which we can write it as r equal to 2 by g becomes of g. That is of g T1, T2 also. Of g T1, T2 also. Right? So T1, T2 equal to r by g implies that r equal to of g T1, T2. So in case of complementary angles of projection, we can have these kind of relations between respective times of flight. That is first T1 by T2, that is ratio. Next product. Of course, you can write sum also, but no significance. What is the sum here? Number 3. That is number 3. Sum T1 plus T2. No significance. Why? Because here 3 unknown quantities. T1 plus T2 equal. T1 means what? 2u sin theta by g. Here 2u cos theta by g. 2u sin theta by g plus 2u cos theta by g. That is 2u by g is common. That is sin theta plus cos theta. Sin theta plus cos theta. Right? Here theta unknown, u unknown. To find T1 plus T2 means here relation between T1, T2, u and theta. Right? Okay friends, with this I am concluding. If you really impressed with my video, please subscribe to my channel C Level Physics. Thanks.